We have this circuit, and I think we have already solved a similar circuit. It's not going to be difficult. We can see that and solve it again, but I have picked it up and see this resistance is not given, so some terms may come out to be dependent upon RL. So what will be dependent upon RL? VO, as we know, does not depend on the load resistor. However, this IO would strictly be dependent on this RL. So based on what we know, this is 0, this is 0, this is 0, this would be 10 volts. So this is 0, that does not mean this is 0. This is very important because of this current source. This current source says that no current, because no current is going to flow in or out of here. This 2 milliampere current is flowing here. So we have a voltage drop of 6 volts across this, and this is at minus 6 volt. We have minus 6 volts here. 10 here means the current here is 10 minus 6 over 16. That is 1 milliampere. This 1 milliampere current is going through this one, a voltage of 5 volts. In the minus 6 volts, we are dropping in voltage. We are going to have minus 11 volts here. And so while VO is minus 11 volt, we have found that does not depend on RL. IO strictly is going to depend on the value of RL. So we can apply KCL here now. So VO minus 6 over 5K, or we could have used that current as well, plus VO minus 0 over RL plus IO is equal to 0. So VO is minus 11, minus because of the value, minus because of the equation, because of the value. So be very careful about that, and we already know what that was. And we know this is minus 1, or we can see it is minus 1 plus VO over RL plus IO equal to 0, going to give us IO is equal to 1 minus VO over RL, or IO is equal to 1 minus 1 plus 11 over RL. So RL must be in, because of this 1, this is 1 milliamperes. So RL must be in kilo ohms for this IO to be in milliamperes. It was a simple circuit.